So friends, we discussed in a previous lecture on risk conscious operation management of complex engineering system. uh, the neuroscience and consciousness, its measurement and brain area that are involved into the consciousness. Now we will see, of course, the part A of this lecture will be neuroscience only, but we will further discuss the subject, and then one of the very widely known techniques in consciousness, that is integrated information theory, and that we will be discussing. And after this, this is part 1 of this state of the art in consciousness. Part 2 will be 2 more techniques we will be discussing, and with that we will conclude. That will be 5th lecture, and we will conclude with that this whole subject of consciousness. So let us see. Now we will be discussing, continue discussing rather from previous lecture, faculties of brain processing of consciousness for forming of perception. Okay. And then computer science technique, that is integrated information theory of consciousness. That is how information and its integration can be treated as a subject of consciousness. So let us continue with the neuroscience theory. Okay, brain faculties and consciousness. Okay, so we know that in previous lecture we saw the faculties which are active in consciousness. It can be seen by MRI, functional MRI, or it can be seen on tomography also, PET scan, positron emission tomography. And then role of consciousness, what role it plays actually, you know. There are, see, first is keeping the cognition at the required level so that normal duties can be performed, number 1. And for emergency condition, the cognition is the one that gets adversely impacted because of stress factor involved. So how consciousness can play the role towards making the cognition stable. Okay. And then cognitive and consciousness, that connection has to be seen. Now we saw in that electroencephalography what are the brain level deep state, what are the signatures that we have, alpha, gamma, beta, theta, spectrum that we saw. Restful state, that is medium, the consciousness levels are minimum. Deep state, sleep, it is lowest. Restful state, it is medium. And the intense cognitive activities, especially during emergency condition, the cognitive levels are very high, and it goes to the activity level or brain wave level goes to 30 or even more in that state. So consciousness works like a bias, as I mentioned earlier. Like we have an electrical circuit, and we generate voltage through DC through battery or AC current, both have voltage common, and consciousness is akin to, not exactly, but it is akin to what it does to the cognition. Cognition is a circuit, let us say electrical board. Consciousness is a voltage bias that we supply to the volt, and you require minimum voltage to keep at certain level so that the operation can be performed. So what is voltage for an electrical system is consciousness for a cognitive function. This has come out with a lot of thinking and experimental activities in the simulator environment when we were developing the C cube B methods, and that is where the role of consciousness become very critical and fundamental. For each of the brain faculties, a minimum level of consciousness is required. It must be normal awareness of the stimuli. We saw that if a patient is there in the hospital, whether he will be able to talk or not talk, that is possible through minimum consciousness level criteria. Whether he will be able to raise the hand, again it is a function of minimum consciousness level area. And other activities, even whether he or she will be able to think what is what or who is who, that also is a level of consciousness. But when we talk about the operational ecosystem, the level should be normal. Normal in the sense that it should be much higher to keep the brain activities alive, whether at cognitive level or at physical level, and have enough strength or enough resources to perform the analysis, to analyze the situation and to form the perception. So that is what it is in RISCOM, this thing. So this figure I have shown you, but here it is more relevant. Processing of consciousness information to form a perception. How perceptions are formed in real life situation, whether you are in the plant area or where you are driving on the road, the processing of the forming perception. For example, if I tell you a car is approaching from opposite direction, how far it is, what is the speed, tentative speed, and then how far the edge of the car which can hit you on your car, that will be there after a fraction of second. And this kind of decision, it distinguishes from a expert driver to normal driver, or even a driver who is learning. And these perceptions should form, and stimuli should process the information. Once the stimuli is generated, processing the information. So I think in this slide we'll understand how in emergency, and the last thing which is more important, our brain or cognitive level remains normal to certain epoch before we make an accident, because the stress factor goes very high. And we thought we will be able to maneuver something in some direction, but it becomes zero. I will give one example. Many people, when they cross the railway track and the train is coming from opposite direction, from the front, we would not know the relative speed of the train, and suddenly train is in front of you, and then you thought you will jump, but the person freezes there, and that is what this miscalculation or judgment or perception goes wrong, and we have the accidents. I mean, if in nutshell somebody has to explain, because the person was confident that he will jump the track, but when he sees, because he doesn't have a sense of relative speed, he sees that train is stationary at certain location, and but then the train is coming at very high speed, right from 60 km per hour to something like 100 km per hour, when it is not taking halt at that station, and that is where the accidents are made. So now let us see this discussion, how we are able to get this concept of perception. The health or quality of cognitive faculties also determine the quality of behavior to external stimuli for formation. External stimuli was here, train is approaching you. For understanding the role of brain faculties involved in the consciousness, let us discuss the visual faculty. Again, I gave you the example of visual faculty only, and for that purpose let us see how the visual cortex, which is called occipital lobe, which processes the information, visual information. On temporal region we have a sensor, it is called eye, which propagate the sensor from here to here, but then there is a role of parietal lobe, dorsal visual pathway, and then we have this ventral visual pathway, how the information is processed and a perception of distance and all it is formed, corner, distance, object, its color. So, for understanding the role of faculties, let us see the visual stimuli as the case in here. There are three major areas: dorsal, ventral, and inferior temporal faculty, somewhere around this, So, the dorsal stream projects the signal to the parietal lobe. Parietal lobe we have here, that formation happens here. Cortex, responsible for movement and relative spatial assessment of object, that deals with where is it. Okay. So, you get the information processing where the object is. The ventral stream deals with the question of what it is. That means what is that object, where it is, distance, what it is, object train. Here the ventral stream evaluates the relative size and orientation of the object. So, this is the job of ventral stream, and sees the size, shape and all the surrounding thing. It distinguishes it with the surrounding thing, and the primary visual cortex deals with the orientation, edge and boundaries. This is a very important information, whether this edge of on my side or other side will not hit me if I jump the track. So, that calculation has to be perfect. In the secondary visual cortex, there are processes dealing with the separation of object from the background. Like if the train color is there, white, and there is a white sky is the background, it is very difficult to distinguish. Okay, there is a train or there is a feeble distinction, or if suppose there is a cloud or there is a fog, then this even if the train has its own color, it is very difficult to distinguish. Intermediate complexities such as geometric shapes and all those things also come into picture. The inferior temporal cortex deal with this is very important, feed forward and back propagation from an end to the original neural signal, and responsible for developing, fine tuning the formation of perception with the original image. So, these processings are very important whether we are in the real life situation, whether we are in the shop floor, whether we are in control room situation, or whether it is a general example of crossing the track when you are this thing. And this is where the miscalculation occurs, and some sort of ignorance also plays the role, but definitely all these things, they are lumped into one thing called negligence and all that. But that is where we are discussing the role of consciousness, because this has been the habit of putting mistakes, negligence as why the negligence occurred. If we can distinguish like this and find out the root cause where things have gone wrong, then probably we will be able to reduce the human error and reduce the risk actually. So, now it is important that we understand which brain faculty is involved in which, so that we can in our tomography or this thing, we can see whether the health is good or not. So, that means we can perform a root cause analysis. If somebody is not able to speak properly or express properly, of course, express properly, it requires a lot of cognition and level of consciousness, and but then speech alone, if in isolation, why the problem is there? Because many times, because of speech and communication, many incidents are observed. Smell. If you have gone to the area and in a plant, and if you could not, one person could not smell anything, a foul smell, another person could smell it. There was a feeble electrical wire burning, insulation burning. So, you can save from an accident. So, smell also has to be placed very. Hearing, if there is a abnormal noise in the pump area you visited, and if you visit every day that area, and if there is a special signature or a foul signature, you hear some rubbing noise or something, or These faculties are very important. A person who is having this faculty in order to the level, and second, his experience that this can avoid this situation. Okay, and then motor control. Motor control comes into the action when you have to take an action. Okay, so these areas represent the motor control. If there is a forming perception and action, if there is a gap, then motor control area has to be perfect. Concentration, planning, and problem. This is very important for control room situation. If any situation arises, then we have to take things in our hand and correlate the signals, correlate from the past experience, and try to see what action should be taken, because action taken in time bound manner can save from many situations. Touch and pressure test is also one of the things. Body awareness. So, if I am not aware of my body, this area is very important. If I am not aware of my body well, the way it should have been, I may end up into the accident. If there is some temperature higher, so, more than normal in certain area, and we are not able to sense it. If there is something wet floor, and if I am not able to notice, then language is very important for expression and communication. This area is governed over here. So, reading and all. If somebody is not having a right speech, he has to take a reading from the panel, and if he is not able to read properly due to vision related issues, and this area is people might fall in the shop floor and the area when we have a cerebellum related issues, and this is how we have covered how the faculties working is important for our performance. And finally, then at the back of it, the emotions play our dedication role, our love for the organization, and all that. So, limbic system is there. Limbic system is responsible for human behavior. I mean, this is embedded in this region. Limbic system, we'll see in next slide. Located deep down in the center of the cortex, above the brain stem. That means somewhere right here actually. And a major part like amygdala, thalamus, and hypothalamus, they work on, and they take care of your emotional component and memory component. Especially this hippocampus plays a very important role in memory center. You saw this. It's very important that we have a good memory. For that you are trained for the plant area. But if your memory is weak, you forget things very fast, then probably when situation arises, you will not be able to recollect what you are supposed to have as a knowledge base to you. So, the decoded memories are there, and produces of the new neurons and provide basis for the plasticity, and therefore responsible for learning faculties. So, I tell training, you should have a very good learning faculty, and then we should have a plasticity to translate this information. These are deep down concepts, and unless until we understand this, like we understand a machinery, a diesel generator or a pump, we will not be able to analyze why the human was doing mistakes. So, in CQB method that we will be discussing in the next lecture, we are talking about, we have created a systematic fault tree, which segment fails, so what happens and where could be the, in fact from the incident itself we can backtrack if we have tools and methods to understand why the mistake had occurred, not because of negligence or sleep or mistake. Those are very broad term and they don't fetch much actually. We normally blame the person, either a pilot or an operator or a engineer, and that, whether we did the right, like it's not a brainstorming issue, it is an issue of analyzing the root cause of the human failure. Then only we will succeed in, and that is what the emphasis are in this subject. Okay. So, now just for five sense organs, we have created this table. It's like you can see the visual perception formed by vision, and eyesight, brain, ventral stream, inferior, this thing they have to work correctly. Okay. And the reference of quality is vision 6 by 6, perception where, desire what, and all that. It can be tested in the simulator room, or it can be tested in the plant area, and for everything to be normal, we can create a checklist chart and all. And then conscious stimuli. Conscious stimuli is vision, observation, perception, subconscious visual perception, and in fact subconscious visual perception is like a very important part of memory and training that we have to dig every time we come across a situation and learn from there. Human attributes are visual awareness, alertness, creation, and these attributes they go into CQB model. Okay, and we develop the human performance factor formula. Failure or anomaly. So since attributes are there, what should be the definition of the failure? So color blindness, judgment of error, compromised vision, deficit in movement, all these things are. So don't you think we are going towards the science of consciousness even for the stimuli also? Okay. Now next, if you say hearing, the auditory perception, it was a visual perception. Auditory perception, we have here auditory pathways. I think I have one slide where auditory pathways either today or sometime in human factor we will see that. And then brain faculties, collateral nerves and auditory cortex is temporal lobe, how they are involved actually. And then reference quality are articulation of index and speech intelligibly, index or intelligibility, and then auditory context, and then perception subject, perception of where, perception of what, and comprehension. Comprehension is very important when we hear something and then we create our own model of what to do actually. Consciousness, listening and grasping, these are the two consciousness stimuli, and then attributes are listening and grasping, inference, parallel processing, audible, filtering and clustering, and decoding what we want actually. Then failure mechanism, hearing impaired, this could be one reason. Deficit in the ability to detect and change the pitch, and then damage to the auditory system. So this you are not getting the auditory information. There is one auditory information, and then other thing is forming a perception which happens at the brain level by respective brain faculties. Similarly, we have gone for executive functions. Executive function means all these senses and then taking decisions. So basically it is the cognitive processing is involved, and then the intelligent quotient is the normal scale that we have over here. The 100 IQ should be less than or equal to 120, equal to 120. Between 100, it should lie between 100 and 120 for a normal function, and executive function brain faculties which we have here. And then prefrontal lobe, as I mentioned you, all this processing happens in the prefrontal lobe, in the cerebrum, long term memory and cortex and all these things. We have limbic system for processing of emotions. And then again the intelligent quotient I mentioned here, here also, and then conscious thinking and brainstorming, attributes, leadership, management, these things are there, and the erroneous judgment and all, not thinking responsibly, unethical or immoral, you can say conscience, that factor comes into the picture. You have to use these attributes into the human modeling. Touch and sensory cortex, smell and speech, I have already explained to you, and these are various attributes that have been classified, and that way we have a complete model of 5 sense organs which are very important for forming perception or analysis or for any evaluation, whether at on-site or during diagnostics or during analysis situation. So now we saw how sense organs and neuroscience, they played out to help us understand the consciousness. Now let us see certain theories which are there. Like I have proposed CQB model. This is an integrated information theory, and it is proposed by Professor Giulio Tonini a neurologist, again a neurologist, but it is a computational theory. So maybe some joint effort and all. So because it talks about the integrated information theory of consciousness proposed by Tononi. Assumptions of this model are consciousness exists and it is there, because the present science doesn't is having a dilemma. If you see David Chalmers' assumption, the problems in consciousness, So here it says it assumes, because any research starts with the assumption or postulation, because all the variables will not be set variables. So consciousness exists is the basis of this theory. Theory of consciousness presents theory and mathematics of consciousness, and is of how it can be measured. That means how consciousness can be measured, and this is a phi is very central to consciousness. IIT is a symbol used for representing integrated information theory. So this is a measurable attribute that Tononi has proposed. Basic premises. IIT has its premises on two phenomena, properties of consciousness. These are differentiation and integration. That means it works for information which comes. It is used for availability of very large number of experiences, and there should be differentiation, and then integration, the unity of such experiences. So these are the two attributes or basic premises on which it operates. And then axioms of IIT are, the basic framework of IIT is built around the 5 axioms. These are that the consciousness experience exists intrinsically, okay, has composition and structure. They are nothing to be explained actually. The information said that the expert experience is specific and you cannot generalize, is integrated, that is unitary or defined, one of the postulates, and then is exclusive, and it states that the consciousness is definite. Okay, so these are the axioms of consciousness. Axioms means these have been ascertained at the scientific level. Further, there are postulates in IIT corresponding to these axioms. So each axioms require a postulation. Role of postulates. These postulates provide physical description of the axioms. The theory lays down the framework that tracks the procedure from phenomena and experience to physics. The procedure involving neural mapping in brain towards offering the physical substrate, so that link for every experience a set of neural correlates. So you can say neural correlate of consciousness. For every experience there will be neural correlate of consciousness, and the integration is at the end of it. The irreducibility of conceptual structure is measured by integrated information symbolized by phi. So phi is one of the symbol that characterizes the integrated information theory. Now salient postulates of axioms in IIT are, there are 5 axioms, as I mentioned in the previous slide. The intrinsic nature of the consciousness. It states that the physical substrate of consciousness, PSC, this is a new thing that we have seen. Physical substrate of consciousness also exists intrinsically, and then in turn, for something exists intrinsically, it must be a cause effect power. So it should have a cause and it should have an effect also. You can see some image is there, and then you have intrinsic nature of experience. What is the experience you have from this image, And then composition. What is the composition? The axioms of composition state that the experience is structured, composed of several phenomena. The corresponding postulate for composition state that the PCS, that is physical substrate of consciousness, also follow the cause effect phenomena. Okay. Information. the state that the PCS must specify cause effect structure of cause effect phenomena and this one. So this is, we have here third one, and then fourth one is integration. Sometimes you are required to integrate postulates of integration. It said that the cause effect structure of the PCS must be unitary, that is, it should be irreducible. And then exclusive, the experiment should be exclusive. Postulate of exclusive, that the consciousness is discrete in content and spatio and temporal domain, in time domain as well as space. It should be discrete phenomena, and these are the things. Probably you can get the right thing meaning while you read this thing on this right side. And this particular thing I have taken from Wikipedia, and just to have a better clarity on what we are trying to talk about, the postulate of the conference. Now, major observation of IIT, that is integrated information theory, is the major procedural element of the IIT involves this clinical research or characterizing the experience, formation of conceptual structure, finally mapping of PCS on cortical areas, that means on the front area of brain, and this is a complex, recourse consuming and demanding task. Okay. So that means whether you can be, sometimes the research becomes, or the subject becomes limited because of the complexity involved into this, and bringing it to the public domain. So this is what it is trying. There are some critics of IIT regarding the definition of consciousness. Even though IIT has made a huge mark in the consciousness research, but looking at the approach, it might be more suitable for clinical application. While the larger area of the consciousness research, which deals with the human behavior during engineering application, may be little far-fetched teams. This is one of the important critics of IIT. It might work in the neuroscience domain, in a healthcare domain, but when we want to infer information on human behavior, which is much more complex, this might be a limitation. Finally, IIT concludes that consciousness is fundamental quality. That is, it is graded and it is present in the infants and animals. And finally, conclusion is that it should be possible to build conscious artifacts. Every research has got some limitation and strength, and that is why we are talking about IIT. That is, here we have critics and we are showing the strength, but we are not generalizing, but we are saying the critical component of the consciousness, and these comments are typical to any R&D activity. So that's why I mentioned this is really a R&D topic. What we have now is that we'll go into lecture 2, where we'll discuss the remaining 2 approaches for consciousness research. Thank you.